Welcome back, dear students. This is Dr. Biju Vasudevan, and this course is Calculus 2 for week 12. We discussed chapter 6.9 hyperbolic functions. In this section, we will study certain combinations of e raised to x, and e raised to negative x. We call them hyperbolic functions. And these functions, which arise in various engineering applications, have many properties in common with the trigonometry functions. The similarity is somewhat surprising, since there is little on the surface to suggest that there should be any relationship between exponential and trigonometric functions. And of course, when you see this one, we will write it as just like a sine hyperbolic, cosine hyperbolic, right? We call it sinh and gauche. When you will be surprised to see whether they are anywhere related to sine theta, sine x, or cosine x. Yes, there may be some relations. There are relations between sine and sine hyperbolic, cosine and cosine hyperbolic, but it's on the complex plane, in the field of complex numbers. So that's not in our syllabus right now. So we never try to relate them here. We study them hyperbolic functions, the combination of exponential function. See here in this introduction page, exponential x e raised to x has been expressed as sum of two terms. This first term is an even term, the second term is an odd term. We call the first part as cosine hyperbolic, the even and the odd part as sine hyperbolic. So this is called sinh. You see, read it here. We read it sine hyperbolic x or sinh. This is cosine hyperbolic x or gauche. Tangent. That's the third one is tangent. When you divide sine hyperbolic x divided by cosine hyperbolic x, you will get tan hyperbolic x. That will be, can you guess what will be tan hyperbolic x? Which will be e raised to x plus minus e raised to minus x. This term in the numerator, and in this term the denominator, e raised to x plus e raised to minus x. So all these functions are called hyperbolic functions, and there are 6 functions as usual. We know sinh, cosine, gauche, and tan. In the similar way, we can derive secant hyperbolic x. We called siege. There will be, we can derive what is it, 1 over cosecant, 1 over gauche, isn't it? 1 over gauche. So invert the gauche, this one, that's it. 2 over e raised to x. So all the formulas of the hyperbolic function, hyperbolic, sine, cosine hyperbolic, cosine tangent, tangent hyperbolic, all the equations have been listed here. This is sine hyperbolic, cosine hyperbolic, tan hyperbolic, cotan hyperbolic, secant hyperbolic, cosecant hyperbolic. Pronunciation has been given here: cosec, sec, cot, tang, gauche, sinh. In this way we pronounce all these functions. They are hyperbolic functions. Why this is called a hyperbolic function? In the case of when you take x is equal to a cosine theta, y is equal to a sine theta, trigonometric functions, you will find x square plus y square will give you circle, a square. But if you choose x is equal to a cosine hyperbolic x and y is equal to a sine hyperbolic x, you will find x square minus y square will be a square, not plus square. Use the definition of cosine hyperbolic, sine hyperbolic given here and try this one. You will get x square minus y square will be equal to a square. So this is an equation of the hyperbola in this form. This is x-axis and this is y-axis. So this combination gives from the hyperbola. So we call it hyperbolic functions. Okay. Some the graphs. Graph of all the 6 functions. You see the graph of gauche. I think it will be failed if you apply a horizontal line test. In general, it is not 1 to 1, but if you restrict the domain from 0 to x, it is 1 to 1. But here change is 1 to 1, and tan is 1 to 1, and this cot, sec, cosec, all are 1 to 1. Sec is not 1 to 1. This is the reciprocal of cosine hyperbolic, and so you can say these two are not 1 to 1 in general, but if you restrict the domain from 0 to x, it will be 1 to 1. Fine. So the domain and range have been analyzed here, where it will be applied. In the case of, when a homogeneous flexible cable is suspended between 2 points with a telephone cable cable line hanging between 2 poles, it forms a curve called catenary. So whenever there is a case of catenary, the equation is y is equal to a times cos x over a, cosine hyperbolic x over a plus c. So in this kind of arc-type structures, we need to use hyperbolic functions. So hyperbolic functions are useful in engineering structures. Some identities of hyperbolic functions, just like our trigonometric functions. Sum of them is equal to cosine. We know first part is even part in the introduction of hyperbolic. Second part is even odd part, so sum of them is exponential x. Subtraction of them, cosine hyperbolic minus sine hyperbolic is exponential negative x. So this is the important identity. We know cosine square x plus sine square x is equal to 1, but here it is cosine hyperbolic square minus sine hyperbolic square is equal to 1. Some 1 minus tan square, some identities is equal to secant hyperbolic square x. Similarly, there are some. So cosine hyperbolic is even function, sine hyperbolic is odd function, and just like our sine a plus b, cosine a plus b, there are 4 important formulas. Just to collect these identities may be useful to solve some problems. And the definitions of differentiation. And remember, if you take some, we can verify every proof here, every result here. This is, let's do it for sine. Then when you differentiate sine, it will be cosine hyperbolic, it will be cosine hyperbolic, and then differentiate u by using chain rule. So how do you verify this? If you take y is equal to sine hyperbolic x, you can write it e raised to x minus e raised to minus x divided by 2. Now differentiate, what do you get? When you differentiate, see 1 by 2 is constant, keep it outside. When you differentiate e power x, it is e power x minus, differentiate e power negative x, e power negative x, and this negatives, when you differentiate, it will be giving you negative 1. So the answer is e power x plus e power minus x divided by, this is nothing but cosine hyperbolic x, isn't it? So when you differentiate cosine sine hyperbolic, it will be cosine hyperbolic. So if u is a function, then differentiate u with respect to x. That's it. So in this way, you can verify all the trigonometric, all the differentiation of 6 hyperbolic functions, and obviously you will get the integration formula from the, when you differentiate sine, you get cos. So when you integrate cos, you get sine hyperbolic. So in this way, you can connect all these formulas. There are 6 for all the 6 cases, isn't it? Okay, when you differentiate tan, it will be secant square as, just like, see, there is no negative sign when you differentiate cosine or integrate sine. There is no negative sign. So negative sign appears here for cot and cot hyperbolic and secant hyperbolic and cosecant hyperbolic. There will be negative sign for all the 3 terms. Similarly, when you integrate those terms, you get negative back. So remember all these rules, we need them to find the derivative of the problems. Next is inverse hyperbolic functions. So from the definition of the 6 functions, we know, we have seen that what is it, cos and sec are not generally 1 to 1, isn't it? So for one-to-one function, others are one-to-one. So we can find directly inverse for these functions in their entire domain. But when you want inverse for these two functions, you need to restrict the domain. That's what given here. When you restrict the domain, you get inverse for everything. This is inverse function for the graphs of the inverse functions. Y hyperbolic, inverse of sine hyperbolic x, inverse of cosine hyperbolic x, inverse of tan hyperbolic x. Inverse is it's a the reflection about y is equal to x, isn't it? So go through this graph and the general information here it is. All the 6 functions, the inverse of all the 6 hyperbolic functions, isn't it? And it's a range domain have been given here. When sine hyperbolic inverse of sine inverse of sine hyperbolic sine hyperbolic x is equal to x is not always true. It's always true here, but not for cos. It's not always when x is positive, because it is not one-to-one in general, right? See all the 6 cases here, when it is possible to apply inverse of the function. We know inverse of a function of f of x is equal to x, but it's not true for all the cases here. Under some restricted domain is true for other functions. Check here and this one. Fine, let's go to the here some different relations between hyperbolic functions and natural logarithms. The inverse of the hyperbolic functions and natural logarithms. Okay, we can prove this one. I will show you one of the proofs, and then if you don't remember these rules, you can derive this. One. You can take for example. Okay. For example, I will show you the proof. Which is we are going to see the proof for sine hyperbolic inverse x. We take this is equal to y. Okay. Now we write y is equal to e raised to y minus e raised to, this is sine inverse x. Okay, sorry, this is I will write this one differently. What is given is different, isn't it? And what we are going to verify is y is equal to sine hyperbolic inverse x. So what is sine hyperbolic y? When you take sine hyperbolic on both sides, it's generally true, isn't it? It is x. Sine hyperbolic y is equal to x. So sine hyperbolic y can be expressed as e raised to y minus e raised to minus y divided by 2 is equal to x. Apply 2 on the right side, e raised to y minus e raised to minus y is equal to 2x. Now when you take everything to the left, e raised to y minus e raised to minus y minus 2x is equal to 0. Multiply by e raised to y, this equation you get, this is e raised to y square. E raised to y into e raised to negative y, it will be 1 minus 2x into e raised to y, which is equal to 0. Rearrange them, what you get? E raised to y whole square minus 2x e raised to y minus 1 is equal to 0. This is a quadratic equation in e raised to y. If instead of e raised to y, if you choose u is e raised to y, you will get, if you take u is e raised to y, you will get u square minus 2x u minus 1 is 0. It's a quadratic equation in u. Now we have a formula to find the solution of u. U is e raised to y, isn't it? Which is minus b plus or minus square root of b square minus 4ac divided by 2a. And you remember a is 1, b is minus 2x, and c is negative 1. And when we use all those results here in this equation, u is 2y, negative b is b 2x, plus or minus b square is 4x square, 4ac, 4 times a and c, negative, plus, so you get plus 4 divided by 2, divided by 2. So simplify this one further. We will write it here. What is it? E raised to y, which is 2x plus 4x square plus 4 over 2, isn't it? So 2 can be cancelled in the numerator. E raised to y will be x plus 4 is out, so it will be 4 is out, and as 2 can be cancelled in the denominator, it will be x square plus 1. So when you take ln on both sides, e raised to y becomes e raised to y becomes y. Y is ln of x plus square root of x square plus 1. But we know ln y is, we know what is y. In the beginning we have assumed y is sine hyperbolic inverse x. So sine inverse of some hyperbolic x is ln x plus square root of x square plus 1. In this way you can verify all the other rules as well. So we have verified this one for cosine over tan over. You can check this way. Fine. Next, the formulas of sine and the inverse. See, derivatives of the inverse functions. One, I will prove one of them, and then the rest you can check. Okay. What we ought to do? Prove the derivation of the formula for sine inverse, derivation of sine hyperbolic inverse. Sine hyperbolic inverse u. Let us take it x, and then we can write it for u if there is any function, isn't it? Okay. Let's take y is equal to sine hyperbolic inverse x. Therefore, sine hyperbolic y is equal to x, isn't it? And by the first rule of derivation of the inverse function, we know that dy by dx, y is inverse function, then it is 1 over dx by dy. Here you can find dx by dy. When you differentiate sine hyperbolic y, you get cosine hyperbolic y. That's it. So this is 1 over cosine hyperbolic y. And now you should remember some identities of hyperbolic function. What is cosine hyperbolic? The relation between cosine hyperbolic function. Cosine square y minus sine square hyperbolic square y is equal to 1. So cosine hyperbolic square y is 1 plus sine hyperbolic square y. So this can be written further as 1 over 1 plus sine hyperbolic square y. So 1 over, this is under square root. When you want cosine hyperbolic y, you get you got to take square root 1 plus sine hyperbolic square y, isn't it? But sine hyperbolic square y is x, so this will be under 1 square root 1 plus x square. This is for sine inverse x. If this function is dy dx, it is sine hyperbolic inverse u can be any function of x, then you replace the same formula 1 over 1 plus u square, and then differentiate u by using chain rule. That is it. This is what given in the case of this So the results are tabled here. You can try in the similar way for all other functions. You don't need to derive the formulas. You need to remember them for using them in the exercise problems. So there are integration formulas also. When you integrate this part, you will get this one. When you integrate cosine hyperbolic, you will get this one. Cosine hyperbolic inverse differentiation of this one will be this one. Integration of this one will be this one. So in this way you connect them, and let's use them in the exercise problems. Now solve them. So there are 3 and again 3 and finally one more problem. We will conclude with this one, isn't it? Let's take two problems from this collection. This I leave to you. I try 10. When you differentiate this one y prime, you are about to find y prime. When you differentiate cosine hyperbolic, you will get sine hyperbolic x power 4, and then differentiate this one by using chain rule, 4x cube. That's it. Problem number 11. This one. When you differentiate cot, it will be minus, all the other the last 3 will give you negative, isn't it? Y prime, it will be negative cosecant hyperbolic square x is here ln x, isn't it? So, and when you differentiate ln x, it will be 1 over x. That's the answer here, straight away. There are 3 other problems in this list. We will go ahead with the 21, 25. You can try this one. Sec. When you differentiate secant hyperbolic, it will be secant x tan x, isn't it? So take secant negative with the negative sign. So secant of this is easy, very easy. You can draw an online. When you differentiate secant, the formula, go back to this one. Negative secant hyperbolic x is e raised to 2x, tan hyperbolic e raised to 2x, and then if differentiate e raised to 2x into 2. That's it. Now let's go for 21. And 25. 25 I leave to you. Try this one. I solved this problem. Y prime. When you differentiate ln function, it will give 1 over the function inside, isn't it? 1 over cosine hyperbolic inverse x, and then differentiate cosine hyperbolic inverse by using chain rule. What do you get? It is 1 over square root of x square minus 1. That is it. You cannot directly apply cosine hyperbolic inverse into cosine inverse as 1 y equal to 1. This is true only when x is greater than 0, right? So you should use first derivation of this as u. You can take this term as u, then apply the formula of cosine hyperbolic inverse, and then use chain rule to differentiate this one. Try this one. That's all. And the last problem of this chapter is integration. Only one problem has been given in our collection of problems. So let me substitute the function u as secant hyperbolic x. So what happens when you differentiate u with respect to x? This is negative secant hyperbolic x tan hyperbolic x. We want only dx, isn't it? We want to take this du. So du is equal to negative secant hyperbolic x tan hyperbolic x dx. See, after this tan and the secant cube, secant and the tan along with the dx will be du. So this will be rewritten as integral ln2 to ln3. You want to change the limit? No, we won't change it. We'll be back to this one again. So this term can be written as tan hyperbolic x secant hyperbolic x and then secant hyperbolic square x dx. These two with this one will be du, and this part will be u square. with a negative sign, isn't it? It will be negative sign. Okay. So the integration of this one is u cube over 3. Substitute the lower limit ln to ln 3. You'll get the answer. So when you substitute the limits, what do you get? Replace the value of u. So in the answer, which is u cube over 3, u is secant hyperbolic x over 3. There is a negative outside. This is from ln to ln 3. Now negative 1 over 3 secant is 2 over e raised to x plus e raised to minus x from the definition of secant whole cube. ln 2 to ln 3. Now 2 cube will be 3. 2 cube will be 8. Negative 8 over 3 is outside. So 1 over e raised to x plus e raised to negative x. Upper limit, lower limit. Before upper limit there is a cube, and then this is from ln 2 to ln 3. What happens? I write this side. Negative 8 over 3. First apply the upper limit ln 3. What happens when you substitute x by ln 3? It will be e raised to ln 3, which is 3. So the first part 1 over 3 plus. Similarly, what is e raised to negative x? E raised to negative ln 3. It will be e raised to ln 3 inverse, which is 3 inverse, which is 1 over 3. The second term will become 1 over 3. This is whole cube upper limit. And similarly, try lower limit ln 2. It will be 1 over 2 plus 1 over 2 cube. So this is negative over 3. You get 9 plus 1, 10 over 3. You can write 3 over 10 cube minus 2 into 2, 4 plus 1, 5. 5 over 2. It will be inverted 2 over 5 whole cube. Use calculator to find the solution. You'll get 37 over 3 is 75. That's the end of this problem. That's the end of this chapter. Practice similar problems for your textbook. Thank you very much.